Alright, so for this video, we are going to discuss the differentiation that involve trigo functions. Alright, so let's start with the basic rules on differentiation for trigo function first. Okay, so there are a lot here. There are 6 trigo functions here, right? Sine, cos, tangent, cotangent, cosecant, and secant. Alright, so generally for me, right, usually I will ask students to memorize the first 3 only. Cotangent, cosecant, secant, generally you no need to memorize, but you use either quotient rule or product rule, you can still get an answer. Alright, but the 3 basic ones, sine, cos, and tangent, you have to try to memorize it. Okay, alright, so let's start with the very first one. How are we going to differentiate sine function? Alright, so for your information, to differentiate the sine function, when you differentiate sine, you will get cos. Okay, so this is something that you need to know. Differentiate sine, you will get a cos function. Alright, and after that, the angle in the original question, you just copy lah. So the angle must copy. Alright, must be copied. Okay, so sine become cos, and after that, you need to differentiate the thing inside angle or inside the bracket, and you got f times x, right? Therefore, you put it outside, f times x. Okay, so maybe we discuss a few examples here. Alright, so let's say I want to differentiate sine 2x. Okay, how can I differentiate sine 2x? So differentiate sine, you will get cos 2x. Must copy back the 2x. And after that, you differentiate the 2x here. Differentiate 2x, you'll get the 2. So you put the 2 in front. Therefore, you get 2 cos 2x. Alright. Okay, so another information. Okay, another example maybe. Let's say I'm having 3 sine x plus pi over 4. Okay, so how you get the answer for differentiation 3 sine x plus pi over 4? Okay, so again, sine 3 is a constant. Generally, you just copy the 3. No need to bother about it. Okay, so when you differentiate the sine, you get cos. So you have cos, and then you have to copy back the angle first. Okay, then after that, you look at the angle here. Differentiate x, what you get a 1. Differentiate pi over 4. Pi over 4 actually is a constant. It's a number. Alright, so when you differentiate a number, you get a 0. Therefore, you need to multiply it with 1. Because differentiate x, you get 1, right? So your final answer should be 3 cos x plus pi over 4. Okay, so I hope that you know how to differentiate the basic, how to say, a function for sine. Okay, right, then now let's proceed further. So the next one is how to differentiate cos. So differentiate cos, you will get negative sine. Alright, so just now is differentiate sine, you get cos. And then now you differentiate cos, then you will have negative sine. So please make sure that you know or you find a way to memorize the result here. Okay, differentiate cos got negative, you'll get negative sine. But when you differentiate sine, you won't have any negative, but you will get a cos. Okay, alright, then the process is still the same. When you differentiate the cos, you get negative sine. Alright, then you copy back the angle, and after that you differentiate the angle to get f prime x, and you multiply with your answer. So let us have a look here. Okay, so if I want you to differentiate cos 2x, okay, plus maybe 90 degree, okay, or maybe we will write as not to use 90 lah, maybe we use pi over 2. Alright, so cos 2x plus pi over 2, what do we get? Right, so again, differentiate cos, you get negative sine. Then you copy back the angle first. After that, you multiply with the differentiation of the angle. Differentiate 2x, you get 2. Differentiate pi over 2 is a constant, therefore you get a 0. So differentiate 2x, you get a 2. You multiply it with a 2. Eventually, you will get negative 2 sine 2x plus pi over 2. Okay, so I hope that you can see this. Alright. Okay, then how about if I say I want you to differentiate 1 minus 2 cos, then maybe pi minus negative 2x, let's say. Alright, so again, you are having 2 different terms here, 1 and also something with cos. 2 different terms are because got negative in the middle, right? Okay, differentiate 1, of course you get a 0. Okay, then you have negative 2. So negative 2 is a constant, you just copy. Differentiate cos, what do you get? You get negative sine. Alright, and then you copy back the angle. Okay, And after that, you have to differentiate the thing inside the angle. So differentiate pi, you get a 0. Differentiate negative 2x, you get negative 2. So you have to multiply with negative 2. Sorry, negative 2, not negative 2x. Negative 2. Alright, so you try to simplify everything here. You have you have negative 4, and then sine, then pi minus 2x. So this is the result when we differentiate the cos. Alright, then the next one. When you want to differentiate tangent, you will get secant square. Alright, so this is a bit special. Okay, differentiate tangent, you get secant square. Again, the fx, the angle, you just copy it. And after that, after you do the differentiation, you have to differentiate also the angle inside. Okay, the angle inside the trigo. So when you differentiate the angle inside the trigo, you get f prime x, right? So you multiply your answer with f prime x. Okay, so again, we will try one example also. Alright, so let's say I want you to do the differentiation for tangent x squared plus 1, let's say. Okay, so how to do the differentiation for tangent x squared plus 1? Again, differentiate tangent, what do you get? You get secant square. Then you copy back the angle. Then multiply with what? Multiply with the, multiply with this, the angle that you have, so which is 2x, right? Differentiate x squared, you get 2x, minus differentiate y, you get 0. Therefore, there's 2x here. So you multiply everything, it should be 2x, and then secant square x squared plus 1. Okay? So this is how we actually do the differentiation for tangent. Yeah? Alright? Okay, so is there any other question that I can try again? Wait, okay, so maybe if I want you to do something like this. How about if, let's say, I want you to do the differentiation for 3 sine x over cos x. Okay, so when I want you to do the differentiation for 3 sine x over cos x, it is a fraction, but you cannot differentiate it separately. Okay, if you know how to apply the identity, the simple identity, you will get 3 tangent x, right? Then only you can do the differentiation. So differentiate 3 tangent x, you will get 3. When you differentiate tangent x, you will get secant square x. Then after that, you differentiate the x, you get a 1. So multiply with 1. So I don't want to write it up anymore. So I'm having 3 secant square x. Yeah? Alright, so you will see that these three are the basic differentiation for trigo function, and you have to memorize it. Okay, although the formula will be given in the booklet, but to me, all of these basic one, you have to memorize it so that when you want to apply in the exam, it saves a lot of your time. Okay, instead of you need to spend time to go and look for the formula and so on, better you memorize it. Okay, you'll see the difference. Actually, you can apply the formula faster if you really memorize it, and also you have the idea how to solve the question correctly. Okay, all right. So now, the basic trigo function, you have to memorize the result. Okay, so sometimes in the question also, they will actually try to combine all the different functions together. Okay, so maybe we try a few examples. Okay, like maybe in the previous video, we learned how to differentiate exponential function, how to differentiate the ln function, right? Okay, and then here we learn how to differentiate the trigo. Okay, so sometimes they can actually combine everything together. Okay, so as an example, all right, can anyone tell me what is the answer that I will get if, let's say, I want to differentiate tan e2x? Okay, and also I want you to differentiate this one, e2 tangent x. Alright, so when they combine everything together, you have to know which one is the main function. Okay, and then you follow the idea and concept that you learn. Okay, so this one example, if you compare it now, both also got tangent, also got exponential function. Okay, so which one should come first when you want to apply the differentiation? Okay, so for first example, if you look at this one, the main function is tangent. Alright, then the e power 2x is actually the angle inside the trigo lah. Alright, so now when you want to do the differentiation, okay, you differentiate the function outside first, which is tangent first. So differentiate tangent, what do you get? You get secant square. Then you copy back the angle. And after that, you need to multiply with the differentiation of the angle. So differentiation of e power 2x, what do you get? So again, when you differentiate e power 2x, you get back the original e power 2x, and then you differentiate the power, you get a 2. So you'll see that the function now become layer and become many layers, I can say. So the outermost layer is tangent, and after that, the second layer is e power 2x, the exponential function, and after that, the third layer will be differentiation of the power 2x. So it's layer by layer. Therefore, you need to really understand which is the function that you have to differentiate first. If let's say you choose the wrong sequence, your final answer will be different. All right. Okay. So after you do the differentiation, you have this. Therefore, usually we will put the constant and e in front. So you are having e2x secant square, then e2x. Okay, so make sure you know how to apply the concept that you learned in the previous video and this video, and then how to apply it together. Okay, right. So now let's have a look for the second example here. Let's say I'm having e2 tangent x. Okay, so for e power 2 tangent x, and the e now will become the main function. All right, so how to differentiate e2 power tangent x? You copy back the original thing, right? So you're having e power 2 tangent x, and after that you need to differentiate the 2 tangent x. When you differentiate 2 tangent x, what do you get? 2 is a constant, you just copy. When you differentiate the tangent x, you will get secant square x. All right, then when you differentiate the x, you will get a 1. So I didn't write out as a 1 here at the end. Okay, then I will rewrite it again. It will become 2e 2 tangent x, and then multiply with secant square x. Okay, so any problem so far for this? All right, so if no problem, let's continue further. Okay, how about if let's say I want you to do the differentiation for this? I want to combine maybe trigo together with the ln. All right, so let's say I want you to differentiate sine and then ln x. Okay, and also I want you to differentiate ln then sine x. Okay, so how can you apply the concept that you learned before correctly for this case? Okay, so first part, this one, sine is the main function because the ln x is the angle inside. Okay, so when you differentiate sine, you will get cos. So copy the angle inside. So you have sine ln x equals to cos ln x, and after that you need to do the differentiation for ln x. So how do you differentiate ln x? Okay, so x, you bring it become the denominator, and then on top there's nothing, right? Differentiate x, you get a 1, so you put a 1 here. Eventually, what do you get? You have 1 over x, and then cos x, cos ln x. Okay, and then how about this one, the second one? All right, so the second one, ln is the main function. Okay, so you need to use the step to do the differentiation for ln. So when you want to differentiate ln, the bracket inside the ln, you bring it down, become denominator. And after that, you differentiate the sine x. Differentiate sine x, what do you get? You get cos x. So you put the cos x on top. All right, so when you combine them together, you have cotangent x. Okay, all right, so just make sure that you know how to apply all this together. All right, and then to practice, you have to try more questions and no other choice. Okay, when you discuss, maybe you can discuss some very simple example, but when you try out, you have to try a lot of different questions so that you actually know how to apply the concept correctly. Okay, so we need to memorize 3: sine, cos, and tangent for differentiation. And you will see that for all the sine, cos, and tangent here, we only involve all the differentiation with power 1. Cos power 1, sine, tangent power 1, sine power 1. We haven't start with the differentiation for sine square, okay, cos square and tangent square. We will cover all those later, okay, in the next part. All right, I think it will be in this video, but after this, okay. Right, so all the basic function here we refer to power 1, sine power 1, cos power 1, tangent power 1. Okay. Right. And after that, for some of the students, if let's say you are interested, or maybe you feel that you still have a lot of memory space in your brain, then you can memorize all this. Cotangent, you get negative secant square. Secant, you have negative, you have secant tangent. Cosecant, you have negative cosecant cotangent. But I will advise you that no need to do so because all the result here, usually they will ask you to use a product rule or maybe the quotient rule to prove it. All right, so no need to purposely go and memorize. Okay, so the basic three you have to memorize are sine, cos, and tangent. Okay, then after that, before we go for some example, okay, so there's a very important note that you need to know here. Okay, for all the differentiation, integration, for that involve the trigo, okay, it is only true for the angles which are measured in radian. Okay, only in radian. So for a lot of calculation, when you involve differentiation in your calculation or integration in your calculation like that have trigo in it, generally all the angle automatically you should know that it is only radian, no degree. All right, degree only appear in purely trigo equations only. All right. So for application question that they want you to draw graph in sketch graph for trigo, sine, and all those things. Most of the time for all the calculation part that involve trigo, they only refer to radian, the angle of radian. Okay, so please stay on that. All right, so we will discover this more when you answer more questions later. Okay. All right, so now let's have a look at this example 4. So again, example 4 will be something very basic. I will just let you to try out on your own, and then I only give you the final answer. If you cannot get an answer, please let me know, and then maybe I can figure out what is the step that you do it wrongly. Okay, so for part A, this is what you should have. Okay, and then for part B, part C, part D, part E, and also part F. Okay, so hopefully you try out all this and then you understand how to get the answer. So this one you try on your own. Okay, so what I want to discuss with you is the example 5. Okay, so example 5 is one of the part involved more on application. All right. Okay, so here they give you a diagram and they tell that diagram shows a curve. This is the equation of the curve, which consists of sine and tangent. All right, and the curve is drawing for the x value of f, which is from 0 until pi. So that means on this is 0 and this is pi. So the x coordinate of the maximum point is alpha. So this is actually maximum point and the x coordinate is alpha. They want you to show that alpha is equals to 2 over 3 pi. Okay, right. So how can you show that alpha is 2 over 3 pi generally? So again, this question involves maximum point, right? Okay, so this question involves maximum point. All right, therefore, when you want to start, you have to apply the concept of differentiation because of maximum point, right? So this is 0 and this is pi. Okay, so to find the maximum point, what we need to do is you need to differentiate first. Okay, so you are having y equals to 8 sine half x and then minus tangent half x. Okay, so when I do the differentiation, 8 is a constant, therefore I just copy it. Differentiate sine half x, you have cos half x, and you need to multiply with the differentiation of the angle. Differentiate the half, you'll get half. Okay, then minus, you just copy the minus. How about tangent? Okay, differentiate tangent, you have secant square, copy back the angle. And after that, you need to differentiate the angle itself. So differentiate half x, what do you get? You get a half. Alright, so you try to simplify it first. Okay, so 8 divided by 2, you get 4. So you have 4 cos half x minus half secant square half x. Okay, alright, so to find the maximum point, the second step is after you find the dy dx, you let dx equals to 0. And you try to solve for the x. Alright, so I bring the secant square x over. Okay, so this is what I have. I got secant square, I got cos. So I cannot solve the equation. I have to make everything into a single trigo in the whole equation. Alright, so maybe what I can do is that when I look at the secant square, 1 over secant square. Alright, so 1 over secant square, what is it? Okay, 1 over secant square is cos. Yeah, it's cos. So cos square half x equals to 4 cos half x. Okay, and then now I will see the end of everything is about cos half x. So I will bring it out. Eventually, I will get cos power 3 half x is equals to 1 over 8. Okay, so what's cos power 3 half x? It's actually cos half x power 3, right? Which is equal to 1 over 8. And therefore, cos half x is equals to 1 over 2. Okay? Alright, so to get half x, to get the x, you need to take cos inverse. So what is the basic angle for cos inverse half? Okay, so the basic angle for cos inverse half should be 60 degrees. So 60 degrees should be pi over 3. And therefore, your x is 2 pi over 3, okay, which is your alpha. Okay, so again, if you look at the example here for the solution, you need to know a lot of knowledge actually. The first one is you need to know how to differentiate all the trigo functions first, that's the thing. And after that, you need to know how to find out what is the process of finding out the maximum minimum point, right? So you need to find dy dx, you need to let it equal to 0. And after you let it become 0, you need to know also how to solve the equation that involve trigo. Okay, so how you take the cube and whatsoever, how to find the basic angle, how to get the answer. Alright, so usually for one particular question in A2 level, they will actually need you to combine a lot of small knowledge from other chapters. So please make sure for every single chapter, you are very clear about the small details in it so that you can apply them. Okay, so when I discuss this example with you, I don't know how you feel. Maybe you feel like it looks like very complicated and it's very hard for you to absorb it or to understand it. Okay, but no matter how, if let's say you find out that it's very hard for you to understand, you need to go back and do some revision for the basic differentiation first. Then at least you need to know what is the differentiation, what's the process of differentiation to find the maximum minimum point. And after that, you also need to go back and learn again how to find the basic angle, how to solve the trigo equation. Okay, all these are, if let's say you are not so sure, right, it's very hard for you to complete the whole question, especially in A2 level. Okay, right, so this is what we have for example 5. Okay, let's continue to another example. Okay, so just now I told you that the differentiation just now, everything is about power 1, right? Sine power 1, cos power 1, tangent power 1. Okay, how about if let's say you want to do the differentiation for sine with some power or cos with some power? Okay, so the formula will look something like this. Okay, which is very complicated. Okay, but generally it is not hard at all. Right, so I will show you one example first. Okay, do you still remember the differentiation that we learned before in AS level? Okay, so let's say I want you to do the differentiation for a bracket with a power outside. Do you still remember how we do it? The process is exactly the same. So first, you put the power in front, right? So you're having half, and then x squared plus 4. You copy the bracket, power minus 1 become negative half. And after that, what you do? You do the differentiation inside the bracket. So differentiate x squared plus 4, you get 2x. So you multiply everything together, and therefore you get x, and then x squared plus 4. Okay, so the differentiation of sine and cos that involve the power is exactly the same like what you learned here before. Okay, so maybe I can just straight away take some example to show you because the formula looks very complicated. Okay, so maybe we try something very simple one first. Let's say I'm having sine power 3 and then 2x. If I want you to do this differentiation, okay, how can we do that? Okay, so first, you assume that the sine 2x is a bracket with power 3. Okay, so now this is your bracket, and then you're having a power 3 outside. So to do the differentiation with a bracket with power 3 outside is pull the power in front, copy back the bracket, power minus 1 become 2. Okay, then now you differentiate sine. Differentiate sine, you'll get cos, and then copy back the angle 2x. Alright, so differentiate sine, you get cos, so cos 2x. And after that, now you're finished, you need to differentiate the angle inside. So differentiate 2x, what you get a 2. And then you try to simplify it. 3 times 2 is 6. Therefore, you're having 6 sine square 2x multiplied with cos 2x. Okay, so this is how we actually do it. Actually, the concept is not hard because you learned it before. It's just that now you need to know this kind of question is very similar to our differentiation for bracket with a power last time. Okay, right, so maybe I can show you another one. Maybe we can try out the cos one. Okay, how about if let's say I want you to do the differentiation for this. Okay, maybe differentiate cos. Okay, so maybe we try cos square and then pi minus 2x. Okay, so again, when I want to differentiate cos square pi minus 2x, okay, first you copy the function of cos, the expression of cos with a power square, with a square outside. Okay, and after that, now differentiate a bracket with a power, so the power you put in front become 2. Copy back the angle, power minus 1. Okay, then now you differentiate cos. Differentiate cos, what do you get? You get negative sine. Copy back the angle again. And after that, you need to differentiate the thing inside the angle. So differentiate the thing inside the angle, inside the bracket, you will get 2x. Oh, sorry, negative 2. Okay, so simplify everything. This is negative 2, right? Multiply with negative, multiply with 2, you get a 4. So you have 4 sine pi minus 2x, then cos pi minus 2x. Okay, so this is what we have. Okay, so actually the process is not hard, just that maybe looks a bit complicated only. All right, but it is not hard actually. Yeah, all right. So if no problem, let's try example 6 yourself, part A and part B. I'll give you the final answer. Okay, so part A, if you didn't do any mistake, your final answer should be negative 24, then sine 2x, cos power 3, 2x. And then for part B, you will get 15 sine 6x. They want you to prove your final answer to get 15 sine 6x. Okay, but give you a hint here. Okay, you will need to use a double angle formula to simplify your final answer here. Okay, so the double angle formula that you should use is something like this. Sine 2x equals to 2 sine x cos x. Okay, this is a double angle formula for sine. But when you want to change it become sine 6x, you need to adjust all the angle inside, okay, according to the solution that you have. All right, but no matter how, think about this, how are you going to change your solution become the answer that they want you to show? Okay, then again, the hint is you have to use the double angle formula for sine. All right, okay, so this is what I want to cover for this video that involve all the differentiation for trigo. Again, all the application question will still apply all the knowledge, just that they now bring in all the trigo part. Okay, so after you settle all the example 6, if you found that okay generally should be no problem for you to solve, to do the differentiation, right? You can maybe go and pick some passive question that involve only trigo one. You can have a try and see whether you're able to do it or not. Right? So for the next video, we are going to discuss another 2 rules that you learned before. but we will combine all the concept, all the trigo, all the functions that we learned just now and in the previous video. So we are going to cover product and the quotient rule in the next video. Okay. So that's all for this video. Yeah.